Hi students. So in the chapter of algebra, let us see some introduction how the algebra really helps us in our real life situations and who is the father of algebra and a detailed introduction of algebra. So I would like to present a video which will really help you and motivate you in learning algebra and understand the useful and the importance of algebra.
There have been so many great advances in science over the past 100 years, everything from relativity and quantum mechanics to electronics, computing and space travel. But none of this progress would have been possible without the mathematization of science and the development of algebra. The term algebra can be traced back to the Arabic word al-jabr, which has its roots in the title of a manuscript written around 820 during a time I refer to as the Golden Age of science. This was the period between the 9th and 14th centuries when scholars in the Islamic world first applied the principles of mathematics to science. I'm Jamal Khalili, a British professor of theoretical physics, but born in Baghdad. I'm going to look at how the mathematical underpinnings of science apply today and trace their roots back to this golden age. Aviation is one of the most remarkable achievements of modern science. And in order to be sure that the planes we build stay in the sky, we've needed to master the mathematics of flight. This is Wing Commander Andy Green, who's a jet pilot and a mathematician.
Okay, we are straight, ready to go.
And you have a mathematics background, so you understand more than most the mathematics involved in aviation and flying.
Absolutely. It is a great way to be able to understand how to fly an aeroplane, to understand the dynamics of what's actually going on in the aircraft, because I can actually dig into the equations and understand the science behind it.
The mathematics that I'm interested in is something called a quadratic equation, a square equation, the unknown quantity x times itself.
That square law equation, the essential basic quadratic, is fundamental to how much lift an aeroplane can generate, how fast it needs to fly. It is the basis of all aviation.
It's actually not as complicated as many people might think. If we think about lift, and there are some various constants, and then there's half rho v squared. So it looks complicated with lots of symbols, but if you bracket all this, all it's saying is lift is some number times the square of the velocity.
Very simply, if you go twice as fast, v squared, you will get 4 times as much lift. Which is why aerobatic aeroplanes are powerful. They need to fly fast to do those very crisp, very precise maneuvers. If you want, for instance, to roll the aeroplane, then if you double the speed, you will roll 4 times as fast. At 75 knots, I'm going to let it on roll now. 1, 2, 3, 4, 5, a little over 5 seconds.
When Andy increases his speed v to twice as fast, because the lift depends on v squared, there's 4 times as much lift, so he can roll the plane 4 times as fast.
So that's 150 knots, and rolling left now. Just over 1 second.
Our modern methods for solving mathematical problems like these, involving quadratic equations, go all the way back to the Golden Age. In fact, to the wonderfully titled book Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, which translates as the compendious book on calculation by completion and balancing. It was written by the 9th century Persian mathematician Al-Khwarizmi. Now, Al-Khwarizmi wasn't the first man to solve quadratic equations. They go all the way back to antiquity. But he was certainly the first mathematician to provide the general method, the technique, the recipe for solving them, what we would today call the algorithm, a word derived from Al-Khwarizmi's Latinized name, algorithmus. He was also rightly regarded as being the father of the field of algebra. Even the term algebra comes from the word al-jabr in the title of his book. What's most remarkable about this mathematical textbook, though, is not that it has any equations in it, because Al-Khwarizmi wrote his whole book in words alone.
Al-Khwarizmi's book contains many practical everyday problems of the time, such as dividing up land, paying laborers, or splitting up inheritance. Businessmen and traders would have found the equations particularly helpful. Qatari businessman Ali Sultan al-Hajri grew up in the desert raising camels and still keeps a herd today.
So Ali, these are beautiful camels.
Thank you.
How important are camels in Arabian and Bedouin culture?
Well, camels are very important in the Bedouin culture for transportation, for milking, for meat. It's very important, yeah.
And if I wanted to buy a camel, I mean, what sort of price would they fetch?
Racing camels is very expensive, you know, run between 50,000 to several million riyals.
Wow.
Yes. The beauty camels is very expensive. You're talking about several millions, you know. It's not, this is jealous again.
They're
see?
both jealous,
Yes.
yes, they want the attention.
So it's very, very important, I mean, very expensive, around up to 20 million riyal, yeah, maybe more. A simple one is maybe 5,000, 2,000.
I ask you this because I want to use the value of a camel to carry out a particular mathematical calculation.
Wow.
I want to give you a problem and show you the sort of thing that Al-Khwarizmi wrote about in his book of Algebra. I'm going to use the example of a man who dies owning just one camel, which of course has to be sold. Now, what if that camel fetched 80 dirhams? The man has a friend to whom he bequeaths a quarter of his money. He leaves a widow to whom he bequeaths 1/8, and he has 3 sons. How much does each son get? He would set up the algebraic equation where the unknown quantity, the thing, al-shay, is part of the equation. This is what we would call x in algebra today. So the way I would write it is 80 equals 80 divided by 4 plus 80 divided by 8 plus 3x. 3 sons, each receiving x. That's what we have to work out. Al-Khwarizmi worked through the algorithm, the recipe to work this out. So if I simplify this, I have 80 equals 20 plus 10 plus 3x. So 80 is 30 plus 3x. I take the 30 to the other side. 80 minus 30 equals 3x. 50 equals 3x. And so x is 50 over 3, which, if I'm correct, is 16 2/3 dirhams. This sort of algebraic equation was something very complicated for people at the time. Al-Khwarizmi showed the recipe for carrying out very important calculations that would have been used in everyday life.
Designed using the latest engineering techniques and complex computer modeling. To create such an advanced vehicle, the Bloodhound engineers have solved thousands of equations.
We're going to the limit of modern technology, 1,600 kilometers an hour or 1,000 miles an hour, 40% faster than the speed of sound.
And when traveling that fast, some of the most important equations deal with drag, the force of resistance that the car needs to overcome to reach 1,600 kilometers an hour.
In exactly the same way that lift will increase by a factor of 4 when you double the speed, the drag on a vehicle will also increase. How much drag you will experience is again a square law, and it's even more extreme in the land speed record context because, of course, we're going so much faster. That v squared term is so enormous. For Bloodhound, we're looking at 1,600 kilometers an hour. Square that, it becomes a very big number, and the amount of drag is immense.
To create such an advanced high-speed vehicle, As well as quadratics, the Bloodhound engineers have also needed to solve many other types of equations.
What's so impressive is that Khwarizmi's work on quadratic equations then inspired other later mathematicians to solve even more complicated equations. And another great Persian, Omar Khayyam, who's regarded as one of the greatest medieval poets.
They gave us the final building block, because it's not only when we double the speed we have 4 times the drag, but it takes 8 times the power. It's that
So it's
cubic
2
relationship.
times 2 times
2. And it becomes a very, very large number. It's that V cube which produces such a huge power requirement. The fact they discovered it in medieval times is astonishing.
So, my dear students, learning mathematics is not just learning with x and y, but it helps us to learn how to reach the sky so high. Thank you.